Welcome to the fifth video in the FISAB training series on European fire safety regulations for sandwich panel products. In this video, we will explore the reaction of sandwich panels to fire and learn to differentiate between different classes of reaction to fire performance. Reaction to fire refers to how a product responds when exposed to fire at the early stage of the inception of fire, which is the fire growth phase, particularly how it contributes to the fire through its own decomposition under specified conditions. The following figure illustrates the development of fire cycle from ignition to decaying. Understanding the reaction to fire is crucial for ensuring the safety of buildings and their occupants, as it directly impacts the speed and intensity of fire development. Improvements in reaction to fire performance can be evidenced by longer times to ignition, lower heat release, lower flame spread, and finally, lower smoke release. Proper classification according to EN 13501-1 ensures that materials used in construction meet safety standards and contribute to the overall fire safety of buildings. This helps in preventing fire spread by using materials with appropriate fire resistance properties, which can slow down and contain the spread of fire. The reaction to fire classification system is a standardized method to evaluate and categorize the behavior of building materials, such as sandwich panels, when exposed to fire. This system offers a uniform approach for assessing how these materials contribute to fire growth and spread, and ultimately to building safety. The primary standard for this classification is EN 13501-1, covering factors such as ignitability, flame spread, heat release, smoke production, and burning droplets or particles. The main classes include, for construction products, 7 classes: A1, A2, B, C, D, E, and F. For smoke production, we have 3 classes, S1 to S3. And finally, for droplet generation, we also have 3 classes, D0 to D2. The main fire classification for construction products, such as sandwich panels, is based on combustibility. A1 class, for example, refers to non-combustible products and no contribution to fire. A2 class is for limited combustibility and minimal fire growth products, whereas D class refers to combustible products with acceptable fire growth for some uses. E class, on the other hand, is for combustible products with significant fire growth. However, F is for no performance determined or below class E. So you notice that A1 is the best performing and E and F are the worst performing regarding non-combustibility and contribution to fire. For the additional classes of reaction to fire, we have smoke production classes and droplet generation classes. For smoke production, S1 is the best performing, and for flaming droplets, D0 refers to no flaming droplets or particles. These are the test methods and combustibility classes for construction products according to EN 13501-1. Non-combustible materials are associated with the first 2 rows of the table, and there are 2 tests to perform to determine the particular class for products in this category. For combustible materials with very limited to medium contributions to fire, there is the single burning item test, and we have 27 combinations of classes in this category. And then we have the ignitability test for E-class mostly. The tests required for product classification to fire reaction performance is done by fulfilling the criteria in this table. For example, for a product to be labeled as Class A1, it must pass EN 1182, 1716, and 13823, for example, and the same logic goes for other classes. A set of essentially 4 test methods are available for classification. We will discuss these tests and how are they done in the coming slides. Here are the 4 main tests that are used to classify the performance of sandwich panels reaction to fire. First is the non-combustibility test, EN ISO 1182, and then the heat of combustion test, EN ISO 1716. Next is the single burning item test, EN 13823, and lastly the ignitability test, EN ISO 11925-2. We start with the non-combustibility test, which is relevant mostly to classes A1 and A2, and it identifies products that will not or not significantly contribute to a fire. The EN ISO 1182 test apparatus is carefully designed to provide accurate and consistent assessment of a material's non-combustibility. By maintaining a controlled high-temperature environment and using precise measurement tools, the apparatus ensures that the test results are reliable and can be used to classify materials according to their fire performance. The vertical furnace is a cylindrical electrically heated chamber. It is capable of maintaining a constant temperature of 750 degrees Celsius throughout the duration of the test. It is typically made of heat-resistant materials and it has an inner diameter of approximately 75 mm and a height of around 150 mm. The electrical heating elements provide uniform heating, ensuring that the sample is subjected to consistent thermal conditions. The specimen holder is designed to securely hold the cylindrical test specimen in a vertical position within the furnace, and it is made of a heat-resistant metal to ensure that the specimen remains stable and does not interfere with the measurements. The holder is constructed to accommodate the specimen size, typically around 45 mm in diameter and 50 mm in height. Before testing, the specimen should be dry in 60 degrees Celsius in an oven for 20 to 24 hours, and then cooled down in room temperature before taking the weight of the mass. For sandwich panel testing purposes, 5 samples of the core materials are used, such as mineral wool or PIR. The test results are recorded, such as the temperature rise of each furnace temperature in degrees Celsius, the average temperature rise for each of the 5 specimens, the mass loss in percentage, and finally the duration of flaming in seconds. For a product to be classified as A1, it needs to fulfill 3 criteria. 1. The average temperature of the product should not exceed 30 degrees Celsius. Second, there should be no sustained flaming. Third, after cooling, the average mass of the product should not be more than 50% of its original mass. For Class A2, the average temperature should not exceed 50 degrees Celsius and the average duration of the sustained flaming should not exceed 20 seconds. And finally, The average mass should not exceed 50% of the average original mass. This video should help you visualize the procedure of conducting the non-combustibility test.
In this video, we look at the test standard AS 1530 Part 1 and ISO 1182, which is used to determine the combustibility of a material based on its reaction to fire. The specimen must be a homogeneous material, nominally 50 mm in height, 45 mm in diameter and 80 cm cubed in volume. A 2 mm hole is drilled from the top of the specimen to the centre of the specimen to accommodate a thermocouple. The specimen is placed into a furnace that has been preheated to and stabilised at 750 degrees Celsius. The test is run for a minimum of 30 minutes and monitored both visually and through a continuous recording attached to two specimen temperature sensors, one placed at the centre of the specimen and the other on the surface. The test is repeated for 5 specimens. To be classified as deemed non-combustible, a material must not cause a significant rise in temperature within the furnace nor exhibit sustained flaming for more than a minimum of 5 seconds.
Next reaction to fire classification test method is heat of combustion test, EN ISO 1716. Again, this test is relevant to classes A1 and A2. In this test, potential maximum total heat release is determined after completely burning the product. In other words, we are determining the heat of combustion or calorific value. This test is crucial for assessing the fire risk associated with building materials, as it provides an understanding of the maximum energy that could be released during a fire. The heat of combustion of non-homogeneous products, such as sandwich panels, shall be determined separately for each layer. More on that can be found in the EN 1716 standard. The specimen is combusted completely in oxygen atmosphere inside a high-pressure calorimetric bomb, heating up the water surrounding the bomb. The calorimeter measures the temperature rise of the water and calculates the gross heat of combustion, also known as PCS. Here is an example of the test apparatus where you can see the crucible, item number 8, which is a container in which metals or other substances may be melted or subjected to very high temperatures. The sampling of test specimen should be according to SFS EN ISO 1716, clause 3.2. You can check the standards for more info. A product shall be evaluated through each of its components, taking into account the rules for non-substantial components. If a non-homogeneous product cannot be delaminated, its components shall be provided separately. Prior to conducting a test, the bomb calorimeter is calibrated by determining the water equivalence of the apparatus using a standard organic compound, benzoic acid, of known calorific value. A specified mass of 0.5 gram of the powdered or chopped specimen is mixed with an equal amount of a combustion aid, benzoic acid, and placed in the crucible directly in the form of a pellet. If complete combustion cannot be achieved using the crucible method, the test specimen can be made by wrapping cigarette paper around the specimen and benzoic acid mixture. The bomb is then filled with pure oxygen and pressurized and then exploded. The calorific value is determined by measuring the temperature change resulting from the reaction within the bomb. The calculation of the gross heat of combustion of the specimen is determined using this equation. The correction of the temperature is required by the exchange of heat with the exterior. For the test result, the water equivalent, E, of the calorimeter is determined by making at least 5 determinations of the gross heat of combustion of pellets of 0.5 gram to 1 gram of certified benzoic acid. The criteria shown here apply for the average test results from the 5 parallel tests. To achieve an A1 classification, a product must meet the following criteria. For classification A2, the limits of gross heat of combustion are higher. A, B, C, D, and E further details the rules of the criteria. Next fire classification test method is EN 13501-1, the single burning item test. This test is considered as the backbone of the Euroclass system for building products. The test results are relevant to classes A2, B, C, and D, and sometimes for class A1. This test assesses how much a product might contribute to fire development in a scenario where a single burning item is placed in the corner of a room close to the product being evaluated. In this test, the specimen is exposed to a 30 kilowatt diffusive flame with combustion gases collected by the exhaust hood for analysis. This analysis uses oxygen depletion to calculate the specimen's heat release rate. Smoke production is measured by how much a light beam is blocked by smoke in the exhaust duct. Additionally, we observe the burning behavior for flame spread and check for any burning particles or droplets. Test specimen should represent the actual product, including any joints. At least 3 specimens are required for a complete test, with additional tests possible for variations like thickness or density. The test results are calculated using specific methods and formulas outlined in EN 13823 Annex A. Key terms include FIGRA, which stands for fire growth rate, THR for total heat release, TSP for total smoke production, SMOGRA, which represents smoke growth rate, and LFS, referring to lateral flame spread. The following graphs show the heat release and smoke production during the fire test over 25 minutes. For each test, the smoke production behavior of the product shall be given as the graphs and calculations of the average smoke production (SPR) for the time interval between 0 seconds and 1500 seconds, the total smoke production (TSP), the smoke growth rate index (SMOGRA), and finally, the total smoke production within 600 seconds, also referred to as TSP 600S. For each test, the product's behavior in producing flaming droplets and particles is observed and recorded, noting whether they have occurred or not. The test results described here can be used for assessing a classification according to EN 13501-1. Normally, this is done based on the average of 3 single tests. If the results do not match the predicted classification, 2 additional tests can be done and the best and worst results will be excluded from the evaluation. The test results described here are based on a 10 minutes evaluation period. The entire exposure period is 20 minutes. If the specimen generates too much heat during the second part of the exposure, the test results are not valid. This way, products which perform well in the first part of the test but burn excessively during the second part are excluded from the classification. Here is a video of a single burning test to help you visualize the test procedure.
The EN 13823 standard is commonly referred to as the SBI test, where SBI stands for Single Burning Item. The ignition source that's used in the test is designed to replicate a waste paper basket fire in the corner of a room, and the burner has a power output of 30 kilowatts. The test was specifically developed for the European construction industry, and principally it's used to assess wall and ceiling linings. But it's also used for some specified products such as linear pipe insulation. The heat released from the specimen is measured using calorimetry. There is a hood positioned above the specimen, and the concentration of oxygen and carbon dioxide in the ducts coming from this hood are measured. As the heat increases, the oxygen levels will decrease and carbon dioxide levels increase. Additionally, we take measurements of lateral flame spread, smoke production, and flaming droplets.
Finally, we have the fire classification test method EN 13501-1, also known as the ignitability test, which is relevant to classes B, C, D, E, and F. The test determines the ignitability of a vertically oriented test specimen when exposed to a small flame, either at the edge or the surface of the specimen. The burning behavior of this specimen is observed for flame spread and the occurrence of burning particles and droplets. Here is a demonstration of the procedure used to perform the ignitability test following the EN ISO 11925-2 standard.
The test is performed in an enclosed combustion chamber which has heat-resistant glass doors on its front and at least one side for access and observation. To allow free ventilation, the chamber sits on 40mm high supports which provide an air gap on the lateral side. The test specimen shall be cut 250mm long by 90mm wide with a thickness of no more than 60mm and clamped into a vertical U-shaped holder. For every test, a minimum of 6 specimens for every flame application position shall be tested. A propane burner is mounted at a 45-degree angle so that its flame application is 40mm above the bottom edge of the specimen at the midpoint on the bottom of the specimen, 1.5mm behind the surface, or at the bottom edge of the center line of the underside of each different layer with the test specimen turned at 90 degrees round its vertical axis. Once the test specimen is appropriately positioned and filter paper to collect any flaming droplets or particles during the test has been laid out beneath the specimen, the ignition source will be lit to a flame height of 20mm. The test will commence the moment the flame is brought into contact with the specimen. The flame can be applied for either 15 seconds, with the specimen observed for a further 5 seconds, or 30 seconds, with the specimen observed for a further 30 seconds. During the test, the flame height is measured as is occurrence and duration of any flaming particles. The result is given as the maximum flame height from the required amount of specimens within that test. Once a product has been tested via the EN ISO 11925 Part 2 test method, EN 13501 Part 1 provides the reaction to fire classification procedure for product classes A1 through to F, with the single flame source test being used within the Euroclass system for product classes B to F. The criteria used according to
The criteria for assessing a classification according to EN 13501-1 for the ignitability test is normally done based on the average of 6 to 12 single tests. For classes D to B, 30 seconds exposure is required, and the flame height should not exceed 150 millimeters within 60 seconds after the start of the test. For the other classifications, such as for E-class, 15 seconds exposure is required, and the flame height should not exceed 150 millimeters within 20 seconds after the start of the test. This brings us to the end of this video. In the next one, we will explore an important topic, which is the fire resistance classifications of sandwich panels. See you in the next video.